Today we're going to look at example 3 in lesson 1.2, and for this one we're going to do the whole thing on the graphing calculator. So didn't quite like the way the book had this set up. I'm going to approach this from our graphing calculator screen, and what we're going to do is we're going to take a look at how the graph of the absolute value of x changes as we multiply different numbers by it. And as you can see here, sometimes we'll put the multiplier on the outside, sometimes we'll put it on the inside, and sometimes we will multiply by a decimal or a fraction, just to see the different outcomes when we multiply a function, either the output or the input, by a different number. Okay, so take a moment, you could pause the video and put in these 5 functions in your graphing calculator. And what you can do is turn them off and on by using the equal sign. If you hit enter when you're on the equal sign, it'll turn it on if it's a dark box around it, and then you can turn it off by hitting enter again. That way you can have several different functions saved in your calculator, but they won't all graph at the same time. All right, here we go. So now that you have all the functions in there, just a reminder, by the way, the absolute value is found under the math menu, and then over to number, it should be option 1. All right, so first we're going to take a look at the absolute value in black versus 2 times the absolute value in red. So our goal here is to see what happens. We're going to hit graph when we multiply by a whole number or a number bigger than 1 outside the absolute value. So the original was this, and the transformed function was this. Now what we're going to call this, anytime the number is outside the parent function, so the function is the absolute value, and the 2 on the outside is going to affect the output. It's going to affect the output. It's going to affect y. Y will be affected. Let's think of how it affects the y values. So what we call this is a vertical stretch, because all of the y's are now taller than they used to be. For example, right here, the point 3, 3 now lives at 3, 6. The point 1, 1 is now, with 2 times the absolute value, living at 1, 2. So as you can see, all of those y values, 3, 3, 1, 1, are going to be doubled because of the 2 affecting the output. You could see that these y values have been multiplied by 2. That's known as a vertical stretch. Next, I've cleared the screen, and we're going to go back to y equals. Let's turn the 2 absolute value of x off by hitting enter. Turn the absolute value of 2x on by hitting enter, right on top of the equal sign. And I want you to focus on, now while this graph might look the same as the red one, we're going to focus on how it's affecting the x's, how it's affecting the input versus affecting the output. Okay, let's go ahead and hit graph. There's the original, and there is the new one. We have absolute value of x versus y equals the absolute value of 2x. Now that the 2 is living in here with the x, I want you to think about how it's affecting the input, how it's affecting x. So by doubling the input, let's think about how the x coordinates have changed. Let's look at the point 6, 6, for example. 1, 2, 3, 4, 5, 6, 6. Don't think vertically, think horizontally. So look left until you get to a green dot. How about right there? That point would be at 3, 6. So the point 6, 6 on the original function is now at 3 comma 6 on the transformed function. So how has the 2 affected the input? How about 3, 3? 3, 3. How is it affected horizontally? Because of the 2, looks to me like this point is at 1.5 comma 3. So for the x's now, 6 gets cut in half. 3 gets cut in half. You only have to put an x value that's half as big in to achieve the same y. So instead of putting in 6 to get to 6, we only have to put in 3 to get to 6, because the function is doubling our input for us. So what's happening is this is called a horizontal compression. So if you're thinking, hey, wait a minute, I thought it was a vertical stretch. It looks like the same graph as the red one we had. You are correct. But it's just how we're thinking about it. The number on the outside, I want you to think how it affects the output. If that number is on the inside, I want you to think about how it affects the input. So out here, how does it affect the output? In here, how does it affect the input? Okay, I'm going to clear the screen. We'll look at the next one. Here we go. I'm back, and I've turned off y3. I'm turning on y4 by hitting enter on the equal sign. We're going to see what happens when we have a fraction less than 1, but greater than 0. So something like 0.5, 0.25, 0.1, outside the parent function. We are outside the bars, and we're multiplying by a fraction. Black is the original, blue is the transformed function. All right. Since it's outside the function, absolute value, I want you to think about how it affects the output. Outside affects output. How does the outside multiplier affect the output y? Let's focus on some points. Like, how about, let's go back to, how about 4, 4? Here's the point 4, 4 on the original function. At that same x value 4, the y on the blue only goes up to 2. That should be logical. It's only half as tall as it used to be. 8, 8 gets compressed vertically to 8, 4. It's half as tall as it was. So a fraction on the outside multiplying the output would produce a vertical compression. Compression is a synonym for shrink. All right, so it presses it down. Let's clear the screen, and we'll see what happens when we have a 0.5 on the inside. Here we are. We're going to have the original in black, and the compressed or stretched. We'll see what happens. Function in orange. We're going to see what happens when a fraction like 0.5 is on the inside next to the x. I want you to think about how it affects the inputs. How it affects the inputs. So on y equals absolute value of x, let's take, for example, the 0.22. Horizontally, how has that been affected? This is going to show up in red. I don't have orange as an option right now. It looks like that point gets stretched out to 4, 2. So on y equals absolute value of 0.5x, the 0.5 is in here, affecting the input. I can think of it this way. My old input 2 has to be doubled to produce the same y value, because the 0.5 is cutting it in half. All right? So instead of putting in 2 to get me 2, I have to put in 4 to get me 2. Instead of putting in, let's see, how about right here, 4 to get to 4, I have to put in 8 to get to 4. because 0.5 times 8 absolute value is what would get me to 4. All right? So all in all, the moral of the story is we have a summary right here. If you have a number being multiplied by the output, if you're multiplying a number outside the function and that number is greater than 1, it'll stretch the y's, or f of x, vertically by that factor. If you have a number on the outside of the parent function, but that number is a fraction, it's going to compress vertically by that factor. So the example here would have been 2 absolute value of x. The example here would have been 0.5 absolute value of x. Horizontally, if you have a number like a inside the function multiplying by x, it compresses. Again, with the x, we have sort of this backwards thing where multiplying by a bigger number shrinks or compresses the graph, like this one. Remember, we had to put in a number that was half as big to get to the same y's in that case. If that number on the inside is a fraction, like this, 0.5, it actually stretched that graph horizontally, as we saw on those graphs on the calculator. So if you want to go back, read this again, or sorry, watch this again, just to let it click before you do the try it. That's fine. You can ask questions tomorrow as well, of course. I'll help you go over these. When you try it here, I want you to use f of x equals absolute value of x. They want to know what happens with j of x when you put a 1/2 in there. All right, so show me on a table of values what happens when you take these x values, plug them in here to get these y values. That's it. See you tomorrow.